we've got a real problem with math education right now. Basically, no one's very happy. Those learning it think it's disconnected, uninteresting, and hard. Those trying to employ them think they don't know enough. Governments realize that it's a big deal for our economies, but don't know how to fix it. And teachers are also frustrated. Yet math is more important to the world than any point in human history. So at one end, we've got falling interest in education in math, and at the other end, we've got a more mathematical world, a more quantitative world than we ever have had. So what's the problem? Why has this chasm opened up, and what can we do to fix it? Well, actually, I think the answer is staring us right in the face. Use computers. I believe that correctly using computers is the silver bullet for making math education work. So to explain that, let me first talk a bit about what math looks like in the real world and what it looks like in education. See, in the real world, math isn't necessarily done by mathematicians. It's done by geologists, engineers, biologists, all sorts of different people, modeling and simulation. It's actually very popular. But in education, it looks very different. Dumbed down problems, lots of calculating, mostly by hand. Lots of things that seem simple and not difficult like in the real world, except if you're learning it. And another thing about math. Math sometimes looks like math, like in this example here. And sometimes it doesn't, like, am I drunk? And then you get an answer that's quantitative in the modern world. You wouldn't have expected that a few years back. But now you can find out all about, unfortunately my weight is a little higher than that, but all about what happens. So let's zoom out a bit and ask, why are we teaching people math? What's the point of teaching people math? And in particular, why are we teaching them math? And in general, why is it such an important part of education as a sort of compulsory subject? Well, I think there are about 3 reasons. Technical jobs, so critical to the development of our economies. What I call everyday living. You know, to function in the world today, you've got to be pretty quantitative, much more so than a few years ago. You know, figuring out your mortgages, being skeptical of government statistics, those kinds of things. And thirdly, what I would call, you know, something like logical mind training, logical thinking. Over the years, we've put so much in society into being able to process and think logically. It's part of human society. It's very important to learn that. Math is a great way to do that. So let's ask another question. What is math? What do we mean when we say we're doing math or educating people to do math? Well, I think it's about 4 steps, roughly speaking. Starting with posing the right question. What is it that we want to ask? What is it we're trying to find out here? And this is the thing most screwed up in the outside world, beyond virtually any other part of doing math. People ask the wrong question, and surprisingly enough, they get the wrong answer, for that reason, if not for others. So the next thing is take that problem and turn it from a real-world problem into a sort of math problem. That's stage 2. Once you've done that, then there's the computation step. Turn it from that into some answer in a mathematical form. And of course, math's very powerful at doing that. And then finally, turn it back to the real world. Did it answer the question? And also verify it, crucial step. Now here's the crazy thing right now. In math education, we're spending about perhaps 80% of the time teaching people to do step 3 by hand. Yet that's the one step computers can do better than any human after years of practice. Instead, we ought to be using computers to do step 3, and using the students to spend much more effort on learning how to do steps 1, 2, and 4, conceptualizing problems, applying them, getting the teacher to run them through how to do that. See, crucial point here, math is not equal to calculating. Math is a much broader subject than calculating. Now, it's understandable that this has all got intertwined. Over hundreds of years, there was only one way to do calculating. That was by hand. But in the last few decades, that has totally changed. We've had the biggest transformation of any ancient subject that I can ever imagine with computers. Calculating was typically the limiting step, and now often it isn't. So I think of in terms of the fact that math has been liberated from calculating. But that math liberation didn't get into education yet. See, I think of calculating in a sense as the machinery of math. It's the chore. It's the thing you'd like to avoid if you can, like to get a machine to do. It's a means to an end, not an end in itself. And automation allows us to have that machinery. Computers allow us to do that. And this is not a small problem by any means. I estimated that just today, across the world, we spent about 106 average world lifetimes teaching people how to calculate by hand. That's an amazing amount of human endeavor. So we better be damn sure, and by the way, they didn't have fun doing it, most of them. So we better be damn sure that we know why we're doing that, and it has a real purpose. I think we should be assuming computers for doing the calculating, and only doing hand calculations where it really makes sense to teach people that. And I think there are some cases. For example, mental arithmetic. I still do a lot of that, mainly for estimating. People say, is such and such true? And I think, not sure. I'll think about it roughly. It's still quicker to do that, more practical. So I think practicality is one case where it's worth teaching people by hand. And then there are certain conceptual things that can also benefit from hand calculating, but I think they're relatively small in number. One thing I often ask about is ancient Greek and how this relates. See, the thing we're doing right now is we're forcing people to learn mathematics. It's a major subject. I'm not for 1 minute suggesting that if people are interested in hand calculating or in following their own interests in any subject, however bizarre, they should do that. That's absolutely the right thing for people to follow their self-interest. I was somewhat interested in ancient Greek, but I don't think that we should force the entire population to learn a subject like ancient Greek. I don't think it's warranted. So I have this distinction between what we're making people do and the subject that's sort of mainstream and the subject that, in a sense, people might follow with their own interests and perhaps even be spiked into doing that. So what are the issues people bring up with this? Well, one of them is they say, you need to get the basics first. You shouldn't use the machine until you get the basics of the subject. So my usual question is, what do you mean by basics? Basics of what? Are the basics of driving a car learning how to service it, or design it for that matter? Are the basics of writing learning how to sharpen a quill? I don't think so. I think you need to separate the basics of what you're trying to do from how it gets done and the machinery of how it gets done. And automation allows you to make that separation. 100 years ago, it's certainly true that to drive a car, you kind of need to know a lot about the mechanics of the car and how the ignition timing works and all sorts of things. But automation in cars allowed that to separate. So driving is now a quite separate subject, so to speak, from engineering of the car or learning how to service it. So automation allows this separation and also allows, in the case of driving, and I believe also in the future case of maths, a democratized way of doing that. It can be spread across a much larger number of people who can really work with that. So there's another thing that comes up with basics. People confuse, in my view, the order of the invention of the tools with the order in which they should use them for teaching. So just because paper was invented before computers, it doesn't necessarily mean you get more to the basics of the subject by using paper instead of a computer to teach mathematics. Well, my daughter gave me a rather nice anecdote on this. She enjoys making what she calls paper laptops. So I asked her one day, when I was your age, I didn't make these. Why do you think that was? And after a second or two, carefully reflecting, she said, no paper,